Welcome to the lecture Philosophy of Science. It's an introduction to philosophy of science. It consists of four major parts. In the first part, I introduce you to the general foundations of philosophy of science. This part consists of 4 units, as you see here. The first unit, today, I will speak about the task and aims of philosophy of science. The next unit next week about the common epistemological assumptions and methodological features of the sciences. Then I come to the classification of scientific disciplines, and finally I speak about general aspects of scientific argumentation and inference. In the second part of this course consists of 3 units. I will speak about the logical foundations of philosophy of science, what kind of concepts are used in science, which kind of statements, sentences, hypotheses are formulated and tested in the sciences in different fields and so on. In the third part, finally, not finally, but the thirdly, I speak about law hypotheses, especially empirical laws and the procedures of their testing. So I assume here that the concepts and the variables occurring in the laws are measurable, empirically accessible, and the law hypothesis is a kind of generalization. It may be deterministic or statistical, and I introduce to you the major procedures how in science different kinds of laws are empirically tested. And then after this I speak about the relation, the subtle relation between statistical correlation on the one hand, which is important in science, and questions of causality, which is definitely not the same as statistical correlation. And in the fourth part of my lecture I speak about scientific theories. This has a separate part because scientific theories distinguish or can be distinguished from empirical laws by the fact that scientific theories contain variables or concepts that are not directly measurable, but only indirectly measurable by way of measuring other variables from which you infer about the value of the theoretical concept or theoretical variable. In social sciences, one often uses notions of a manifest variable, which is directly measurable, and a latent variable here, which is indirectly, only indirectly measurable, indirectly discoverable. In this final part I will speak extensively about concrete examples from science. I will speak about a concrete example from science in case studies all over the course. But in that fourth part I will introduce you into the structure and dynamics of theories at hand of one example coming from physics and the other example coming from cognitive psychology. And that's it. And the last unit will be the possibility for you to do an exam and to acquire a grade for this course. Okay. The course will be based on my book. This is my book, Philosophy of Science, A Unified Approach. And so I would recommend to you to use this book as a kind of a reference for the course. Everything which will be examined in the final exam and which will be relevant for you to get a good grade, is on these slides. So if you have these slides, which I make my slides, which I project here on the wall, they are also available at the internet, at my homepage. You find my homepage at the department's homepage. If you go to Gerhard, to the Department of Philosophy of the Heinrich Heine University, then you go to my name, Gerhard Schurz, click on it, and my homepage opens. Then you go to, in German it's Lehre, teaching, and then you go to teaching materials, and then you find these slides, right? But these slides do not explain everything. They just mention all what is content of this course. And if you look back, then you can use my book, which explains everything in detail. Of course, I must confess I'm not the only one who wrote about philosophy of science, fortunately. So here is some further literature which introduces you into the philosophy of science. This is just a list. You can look it up closely when you look on my homepage and look in the slides once again. So I have recommended some of them as especially recommendable. Of course, all of these books are recommendable, but those in red are especially suited in the sense of first presenting very elementary parts of philosophy of science, being very elemental, and second, being really easy understandable. So these four in red I would recommend to you. So, right, good. So I'm finished with this list now, and now I proceed to the content of the first unit. I just skip to the slides. But before I start with that, I ask you, do you have some questions so far concerning maybe the final exam or the course organization, or other questions, any other questions which you have? No. So if this is the case, then I can go on. Oh yes, well, okay.
Maybe what do you have to do to get to the end?
Yes, this is a good question. For the PN, the final exam consists of 6 major questions, which you have to answer by writing the answer in, say, 1 page. And for the so-called BN, you just have to choose 2 out of the 6 questions and answer them if you were regularly part of the course. Yeah. Okay. So that's, you can choose them. Right. And to get a grade, you have to answer all 6, and it will be evaluated according to a scoring system. And the questions will contain only materials which are on the slides, which are the most the important things of the course. Right. I will not ask marginal matters, because the important things are difficult enough to grasp, and if you master them, you get an A. So, any further questions? Good. Then I start with the first unit. So the questions of the general philosophy of science. First of all, there are, of course, on the one side, general questions, general characteristics of the sciences which are more or less common to all sciences. And there are special characteristics which are special to particular groups of scientific disciplines. I must emphasize, when I speak of the sciences, I mean this word, I understand this word in a very general sense, which is common in Europe, maybe not so common in the USA or in English-speaking countries. So in the sense including not only the natural sciences, but also the social sciences and the humanities. So my notion of science will include all of these 3 groups. And of course, if you have this notion of science, it's a very important question. What are the common foundations of all these scientific groups of scientific disciplines? It's actually a debate in philosophy of science on these questions, a controversy, and I belong to that wing who think there are important commonalities, common methodological features which are common to all these 3 groups of scientific disciplines. And the purpose of working these common foundations, of working them out, explicating them, is typically purpose of the general philosophy of science. But on the other hand, also to emphasize, to focus on the differences between the different fields, the differences, say, between the physical sciences, the social sciences, or the social sciences and the humanities, is an important task of philosophy of science. And I will also, in this course, again and again, come to speak on these differences. for instance, there are special philosophy of science is also in the. I mean, philosophy of science is, so to speak, realized in different communities. It's not only philosophers, majorly, but not only philosophers who are doing philosophy of science, but also members of other disciplines, like there are philosophers of social sciences, and you find them not only in philosophy, but also in sociology, right? There are philosophers of biology. There's philosophy of biology, which is a special philosophy of science, which is not only done by philosophers but also by biologists. Or there's a philosophy of quantum physics, a broad field which is not only done by philosophers but also by physicists. So these are the special philosophy of sciences, but this course will focus on the general philosophy of science. Okay, so what are then the major questions of the general philosophy of science? Well, these are three major questions. Of course, the three major questions are: what are the objects of the sciences, what are the methods of the sciences, and what are the goals and the limitations of the sciences? And these things hang together, right? All these three questions hang together. Why? First of all, and this is a subtle thing, the question, what is the right method of science, right, is of course dependent on what is the goal of science, right? So this is a kind of pragmatic feature of my approach to philosophy of science, which I have from the start. So if you say the goal of science is to produce economic welfare or happiness, I mean that's some kind of thing which I do not start off, because I mean scientific truth are not necessarily things which make you happy or which make you rich, right? As some pragmatic philosophers maybe would have it. So the goal of science has to be defined, and I speak about that. What are the central goals of the sciences? Of course, something like having to do with finding out objective truth, or finding out sustainable, confirmed truth about the world. So what are the right methods depends on what are the goals of sciences. So, and of course, if you have said something about the goals of sciences and demarcated that, then you can also speak about the limitations of sciences. For instance, it is not the task of sciences to declare what are the right political values, right? I mean, this is actually a debate, namely the debate on the status of values in science, where I also will speak about, right? But if that is clarified, then intrinsically there flows something from it concerning the limitations of science. If you really set up clearly what are the goals of the sciences, the epistemic goals, then what are the methods, the optimal methods to reach these goals, and you can speak about what are not the goals, so what are the limitations of sciences. These all hangs together. There was a question?
Yes, could you please name a scientific discipline that is concerned with any actual truths?
I think truth is actually relevant to all scientists in all disciplines, and maybe you mean that what is important for scientists is not truth but successful empirical predictions or something like that, and if they are successful in this respect, then truth is irrelevant. Is that what you mean?
Yes, I do.
Okay. But this is exactly the business of philosophy of science, to clarify these themes, because for philosophers of sciences who have a minimally realistic orientation, as I have, empirical success is the major way to confirm the probable truth of a hypothesis, right? So, I mean, if we are interested in truth, we are of course also interested in, and this is exactly what philosophy of science is about, in methods. How can we find out which hypotheses are probable truth? There's never certainty about truth concerning generalizations or predictions about the future, but there's probable truth. And how can we distinguish between a probably true hypothesis and a probably false hypothesis? And the major method is a probably true hypothesis will be empirically successful in its predictions. It will produce predictions which turn out to be true in our observations. while a probably false hypothesis won't have this property. And on the other hand, if a hypothesis is sustainably successful in the empirical sense, then this is a major argument, and this was a major argument of Putnam, and is involved in a big controversy in philosophy of science. This is a major argument for believing that this hypothesis is at least close to the truth, right? Because otherwise it would be a mirror, as Putnam has argued, for instance, that this hypothesis is successful although completely distant from the truth. But you know, your question already touches topics which I will speak about in the fourth part of the course. We are already in the beginning now. Okay. Good? Good. Good. So, these are the major questions of philosophy of science, and what are the more specific questions in philosophy of science? Well, these are typical questions here. What is the scientific language, right? What is it crucial characteristics of a scientific language as opposed, say, to natural language or common sense language? Presumably it has something to do with how concepts are defined or precisely explicated. What is a correct scientific argument? What is scientific argumentation generally? What is involved in that? Logic, but not only logic, also probability theory is important. We just spoke about that right now in your question, in the answer to your question, that hypotheses, generalizations about the future or the world, non-formal, non-mathematical hypotheses are always uncertain. So not only logic but probability is important for a scientific argument. A further question is, what is a scientific observation? What is a scientific measurement, right? Here it is important to ask, are scientific data, so to speak, theory independent, or are they dependent on certain theoretical assumptions? What are there, is observation theory neutral, or is it more or less loaded by certain background assumptions? Next question, what is a scientific law? What is a scientific theory? In particular these two questions, right? How are laws or theories empirically tested? What are, and finally, what are the criteria for progress in science, right? So, also what is a scientific prediction, what is an explanation, and what is a causal relation as opposed to a non-causal statistical relations. These are the central topics and questions of the general philosophy of science. And all these questions will be dealt with in this course. Although these questions are somehow building upon each other, because, you know, the most complex questions are here and here. For instance, to say something about causality, you need a lot to know about what scientific theories are. In order to say something about scientific theories, you know, you have to know how they are empirically tested. In order to understand what is an empirical test, you have to know what is a scientific observation, what makes it, what is the demarcation criterion here between the observation and the hypothesis, or a measurement and the hypothesis. And in order to test the hypothesis, you have to find out its consequences, so you need to know what is a scientific inference or a scientific argument. Okay, good. Finally, I want to speak something about, about some questions which are in the background of philosophy of science and which are always accompanying us. Namely the question, is scientific knowledge objective? Can it be true? In which sense can we say it is probably true, it is objective, right? To answer this question, we have to know what is objectivity and what is truth. At this question, philosophy of science turns gradually into general epistemology. You know, in philosophy we have this distinction of different subfields of philosophy, and what we call theoretical philosophy in the European world consists of all of subfields dealing with questions of how to find, how to acquire true knowledge. General epistemology deals a lot with common sense knowledge, with general foundations of knowledge, what is observation, right, for human beings and so on. And philosophy of science deals with scientific knowledge, is more specialized. And when we ask what is objectivity and truth in general, it's a typical question where philosophy of science and general epistemology merges, right? And where also epistemology can learn from philosophers of science. Another such general question which will be accompany us in this course is the question, what is the relation between scientific hypothesis, confirmed hypothesis or true hypothesis, and values? Do values play a role in science? Very famous philosophers of social sciences like Max Weber set up the requirement that scientific knowledge must be value neutral. So political values, for instance, should not influence the scientific knowledge, right? Because otherwise it couldn't be objective. But that is not so easy, and of course if you look at this question more closely, it becomes difficult. For instance, of course, you can say, well, scientific knowledge is orientated only on one value, the value of truth, right? But what is truth? You have, I mean, it's difficult to explain what truth is. So then you can go further and ask, what is the distinction between epistemic values on the one hand, which are related to how to acquire truth, which are truth conducive, so to say, and extra epistemic values or non-epistemic values like political values, which have nothing to do with knowledge. And this is the debate on the value neutrality of science, which we will also discuss in this course. And in this debate, philosophy of science turns gradually into a subfield of ethics, namely meta-ethics. Right? Meta-ethics is concerned with the questions, can we justify values at all, right? What is the meaning of value statements or of normative statements, and can we justify them in any way? Okay, good. Finally, I speak a little bit about applications of philosophy of science. Well, there are two kinds of applications. So what is philosophy of science good for is the question here. Well, on the one hand, on the one side, philosophy of science can be applied internal to the sciences, so it's useful for different scientific fields, right? For instance, philosophers of science can give methodological advice and decision support concerning controversial questions in science, like the questions in biology. A typical example is the question in biology, functional explanations or teleological explanations that explain something with its purpose, right? Birds have wings because wings have the purpose to make them fly, to make them able to fly. Are these teleological or functional explanation in biology something which is completely different from causal explanation in physics, or is there a way to reduce the biological explanations to some kind of physical explanations or causal explanations? So philosophers of science can help scientists to answer these controversial questions, right? And the second thing is, philosophers of science can find out interdisciplinary relations between different fields, right? Which also, for instance, took place in the philosophy of the social sciences. There was a movement some decades ago where humanities, the theory of humanoidics, of understanding human language and human speech in humanities, and the theory of understanding actions and the meaning of actions in sociology merged, right? Because they found out they're dealing with more or less the same questions, right? Because they're dealing with the questions how humans express meanings to conspecifics to other humans, right? So here, philosophers of sciences discover the certain subfields in sociology on the one hand and humanity on the other hand dealt basically with the same questions, and that happens quite often. Also, philosophers of science always had a pioneer function for the emergence of new scientific disciplines, right? Like the discipline of cybernetics or systems theory or things like that. So these are the applications internal to the sciences. Now, there are also applications external to the sciences. And here I mention just two very important ones. The first one is a demarcation problem. So philosophers of science have the task to demarcate what is science as a kind of epistemological enterprise which aims at objective knowledge and which really sets up the requirement that scientific knowledge should be somehow objective, so should be subjectively stable and subjectively acceptable, independent from your subjective values or political orientations. So how to demarcate that kind of knowledge which is so subjectively generalizable from subjective belief, right? This is called the demarcation problem. So this demarcation problem played already a role in the 20th century debate, where some quite positivistically orientated philosophers of science wanted to demarcate a philosophy of science like from metaphysics or from other fields in philosophy. And in some sense, these early accounts on the demarcation problem were really much too rigid, right? I mean, they really wanted to eliminate lots of different fruitful approaches in the whole realm of human ideas or philosophical ideas. So the demarcation problem, in some sense, was not lost its fashionability, right? Its attractiveness in the 1960s and 1970s. But then later, it became to acquire new importance. Not philosophical, but social importance. For instance, in the debate that surrounded the debate on in the controversy about creationism, especially in the USA. In this controversy about creationism, you know, there are a lot of movements who argued, well, we creationists have equal rights like the Darwinian evolution theories to be taught publicly in public schools. So the public education system in biology, for instance, in schools should not only tell Darwinian evolution theory, but on par like the Genesis it is told in the Bible, right? There have been certain juridical processes and cases in which this question became really important. For instance, 1981, the Judge Overton in the case McLean versus Arkansas judged against the requirement of teaching creationism in school. And in the year 2005, the Judge Jones, in the case Kitzmiller versus Dover, also decided against teaching creationism in school, side by side with biological evolution theory. And they based their decision explicitly on criteria which have been set up by philosophers of science. So they referred, for instance, to the fact that the thesis of evolution theory are empirically confirmed by a variety of findings, while the thesis of creationism are either refuted by empirical findings, or, I mean, if you go more to subtle forms of creationism, rationalized forms of creationism, they are not confirmable at all, right? They have also applied other criteria to demark, to justify, simply to justify why certain forms of knowledge should be taught in public education systems, because they can be assumed to be probably true, intersubjectively acceptable, right? While other forms of beliefs should not be taught in public school because they belong to what we call subjective beliefs, right? Religious convictions, for instance, religious creeds, political ideologies, and so on. They should be taught in certain units in school, but in the form of a critical discussions of different subjective standpoint, which you can have or which you can't have, and what is the difference. But they should not be taught in school side by side with scientifically supported knowledge like biology, right? So this is again a major reason why the question of what is probably truth in the objective sense is so important, right? So this is an example of the demarcation problem in our time, why it becomes important in our time. But on the same count and in the same sentence, I should mention the second function of philosophy of science, which is equally important, namely the critical function. Namely, there is, of course, all the danger of abusing scientific knowledge for political purposes or for economical values, right? Politicians often justify their political decisions by so-called experts, right? And these experts do not really justify their decisions, but they just this kind of pseudo-scientific assumption that from the empirical findings, the normative decision of the politicians can be justified. So if this thing happens, right, then the task of philosophers of science is to criticize this possible abuse of science. An example of this sort is also the finding of systematic biases, for instance, in pharmaceutical research, where it has been found that surprisingly, right, pharmaceutical research papers find that medicaments of pharmacies as most effective, which were produced by those firms who financially supported the institute, who undertake the research, right? And this correlation then was a matter of a huge controversy in the philosophy of natural science, especially philosophy of medicine. So this is a second function of philosophy of science, namely the critical function to criticize abuses of science, and to distinguish between science and pseudoscience, and to criticize abuse of science. Both functions are important. Okay, so this finishes this part. Are there any questions to what I said so far? Yes?
You mentioned the abuse of science by politicians, for example.
Yes.
There are also ways that politicians could use science which aren't abused, but which might be the proper help to politics by science.
I'm sure there are, right? There should be. I mean, if, for instance, politicians want to find out the safety of a nuclear plant, right? Of course, they have to ask experts to estimate the safety, the probability, right? But they should. I mean, the estimations of the safety of a nuclear plant in terms of the probability of a certain kind of accident, say of a superpower, so it's the most dramatic accident of a melting of the nuclear plants. Of the nuclear substance. These estimations will diverge between different kinds of experts because it's so uncertain to estimate this probability. It's so difficult. The danger of abusing here the word expert or the notion of an expert is so great. So they should definitely invite also say maybe probability theorists who are somehow dealing with second-order probabilities, and which can explain them how uncertain all these estimations are, right? And if you follow the maxim of starting from the worst case, right, then of course the estimation is much more skeptical as when you start from other assumptions. So in this respect, of course, political decisions should be based on scientific knowledge, but they should be based in a quite careful way, and this careful way is task of philosophers of science to say in what it consists, right? Any further questions? Please. If not, then I come to the next point, the method of philosophy of science. So philosophy of science, of course, is itself a discipline who has to pursue a certain method. I mean, you can ask a question, how is it that some people who call them philosophers of science tell the scientists, well, this is the way you should science, right? I mean, what legitimates them to set up certain claims like this is the best method of doing science, right? Oh, how else? If this is not how philosophers of science should proceed, then how else do they come to their claim and to their thesis? And there are two views on these questions in philosophy of science: the normative view and the descriptive view. The normative view is historically older, right? So this normative view says the philosopher of science should say how science should proceed. So the task of philosophy of science is to say in what scientific rationality consists. So it should explain what is rational science. The descriptive view has the opposing opinion. It says, no, philosophy of science should describe actual sciences, how they actually are. Philosophy of science should explain and describe the factual scientists and the factual sciences in the historical development. This is the descriptive view of philosophy of science. Well, prima facie, the normative view is of course quite plausible. Why? Because of course philosophy of science must somehow be distinguished from the history of sciences, right? The history of science as a historical discipline describes the factual development of the sciences, right? Philosophy of science should also be distinguishable from the psychology or the sociology of science, right? The sociology or psychologies of science describe these factual things, but philosophy of science should be concerned with the question of the epistemic status, of the epistemic assessment of scientific hypotheses. It should be concerned with the question, what are the right methods which scientists should pursue to attain probable truth? That is a central question, and to attain not only probable truth but also content-rich truth, which is important, which is significant, and so on. So the normative view was taken, for instance, by Karl Popper and the logical empiricists of the Vienna Circle. These are two very famous and important wings, so to speak, and groups in philosophy of science, and so I write them on the blackboard. So Karl Popper, you know, in the early 20th century, like 1930, he was starting his philosophical influence. His career started a little bit earlier, of course. And he came from Vienna and then moved to England. And his philosophy is quite famous under the name critical rationalism. So his book, which is also quite famous, The Logic of Scientific Discovery, is a paradigm example of this normative view, right? The view of Popper is, well, by simple logical consideration, you can find out how we scientists can, so to speak, attain truth and avoid, in particular, avoid falsity. So his idea is that scientists should set up bold hypotheses, general hypotheses. In the next step, by using logical inference, they should find out what are the consequences of the hypothesis, what are the observable or measurable consequences of the hypothesis. And then they should compare these consequences or predictions of the hypothesis with what they observe. And if there's a conflict, if there's a contradiction between the consequences of the hypothesis and what they observe, they should falsify, they should refute the hypothesis, should eliminate falsity. And by eliminating more and more falsities, what remains is probably true. That is, in short words, Popper's philosophy of science, a core idea, right? So you see, this idea is normative in the sense that it is based on logical considerations, on a priori considerations. There is not much need here to look on factual sciences, how Newton really proceeded, how Darwin proceeded, right? It's just a logical business in this view, philosophy of science. And a similar view was held by the Vienna Circle philosophers. The Vienna Circle philosophers, like, I write it on this side. Oh, so we have although something here, so I go here. The Vienna Circle philosophers three names maybe should be mentioned: Moritz Schlick. They also have been started their activity in the early 20th century, like 1930 or 1926 or so. Otto Neurath, and especially Rudolf Carnap. So, and maybe I mention also Gustav Hempel. These are some important names. They also had this normative view. They were very influential for the development of analytic philosophy of science in general, these two groups, at least in Europe. And their philosophy was called logical empiricism. And of course there are differences between logical empiricism and critical rationalism. But at this stage of my course, at this general stage, what is more important are the commonalities of both wings, and that is, of course, the normative view. The normative view also was propagated by a further philosopher, Hans Reichenbach, who was very close to the logical empiricists. He was active in Berlin, and his group of followers were also called the Berlin Circle. And they corresponded with the Vienna Circle in that time. And Hans Reichenbach was the one who argued explicitly in favor of the normative view by his famous distinction, which I explain to you now, namely the distinction which you see here between the context of discovery and the context of justification. Context of discovery or genesis of a hypothesis, how it factually develops, right? And the context, how it factually was discovered, the hypothesis, right? How it was generated. And the context of justification, how it is justified as probably true, right? For instance, by being empirically successful, by being confirmed, by having success in finding causes or whatever. So the context of justification or confirmation, right? And Reichenbach's argument was very simple. Philosophy of science is interested primarily, right, in the question what makes a scientific hypothesis justified. It's interested in justification question. But for the question of the epistemic value, the truth of the hypothesis, the genesis, the historical development of that hypothesis is completely irrelevant. That was Reichenbach's argument. Therefore, he said, philosophers of science should not take care. There is no need for them to take care about the history of science. There is no need for them to be informed, to get richly informed about the history of science. That is done by historians of science. philosophers of science should focus on the logical relations between theory and evidence or things like that in order to come with the right scientific methods to come up with them. But the problem was that although this argument sounds prima facie plausible, it turned out that the models of the normative philosophers of science, like the Vienna Circle philosophers and like Karl Popper, were simply much too simple, did not really fit with the actual history of science, right? And the person who found that out was Thomas Kuhn. Thomas Kuhn, who launched, so to speak, or triggered the so-called historical turn in the development of the discipline philosophy of science. And the book for which Thomas Kuhn is famous is, so Thomas Kuhn, his book, The Structure of Scientific Revolutions, The Structure of Scientific Revolutions, appearing in the year 1962. And there Kuhn showed, by way of historical analysis, of the development of physics from Newtonian physics to contemporary physics, relativity theory, quantum mechanics, and the development of biology from Linnaean biology. You know, Linné had the theory that all species and genera in biologies are eternal beings. The development of Linné's system of biology to Darwinian evolution theory. And Thomas Kuhn found out that certain central element of these normative models of philosophy of science don't fit to the historical development, don't fit to the actual scientific practice. He even said, Kuhn said, that they are contradicted by the scientific practice. For instance, according to Popper, if a theory is in conflict with observations, with measurements, if the theory contradicts the data, then it is rational for Popper to reject the theory. But Kuhn said again and again, scientists don't do that. Although their theory is contradicted by certain findings, they don't give up their theory, their beloved theory, right? They try to change the theory a little bit, they fiddle around with it, they change it at the periphery, as Lakatos then later found out, but they don't give the theory up. So there was a huge controversy in philosophy of science about this conflict and this challenge of Thomas Kuhn, the challenge of the historical side of the philosophy of science. And within this challenge, that took place in the 1960s and 1970s, right, the descriptive view come up. The view that, no, that was wrong, what these earlier philosophers did. Right. We, philosophers of science, should be descriptive. We should be descriptive in the sense of describing how science really proceeds, right? What Newtonians really did when Michael Morrison's found out that the prediction concerning the ether theory, prediction following from the ether theory, was falsified in the so-called Michael Morley experiment. What physicists really did, what physicists really did. So philosophers of science should be descriptive. They should describe and explain how science proceeds. That was the descriptive view. Okay. Now, in the development in philosophy of science, which was following this debate, it was found out that the conflict is really not as strict and as big as it seemed initially, right? If you have a more differentiated picture of scientific knowledge systems, right, than Popper had. It's not a theory, for instance. It's not simply a statement or a universal implication statement. That's some kind of really ridiculous. A theory is a whole complex system of different assumptions which are organized in certain ways. So, for instance, these things were then found out later on. An important name is in this respect names of philosophers of science, where you can say, with these names, our modern philosophy of science is really starting. It's starting. What we are doing now is in this tradition, which was following up the challenge and the controversy between the descriptive and normative views. And one of the first philosophers who was important here was Imre Lakatos. You see him in my literature list. For instance, Lakatos showed that if you have a more differentiated picture of a scientific theory, being a system of hypotheses, where you have a core of the theory and a periphery, then it's not really any more a logical contradiction between what Popper says and what Kuhn says. It can be somehow reconciled by saying that, well, if there are contradicting data, adherents of the theory don't change the theory core, but they fiddle around at the periphery. And things like that, which I will speak about in the later parts of my course, and not now in extenso. But these developments in philosophy of science then reconciled these two views. And if you look at Lakatos, for instance, falsification and the methodology of scientific research programs, you see what he does. It's some kind of a role model for what other later philosophers of science did. He's very informed about actual scientific practice and has a lot of purely logical considerations in his paper. So he does both normative and descriptive things, and he wants them to bring them together. So what you can say is what is right and what is wrong in this early argument of the normativists is the following. It is right, I mean, at least that is a consensus in the philosophy of science community, that philosophy of science is concerned with the question of the epistemic assessment of scientific hypotheses and theories. Not primarily with the empirical development, right, but with the epistemic assessment, how probably are they true, confirmed, etc., how contentful, how rich in content they are. But in order to answer these questions, it's nevertheless relevant for philosophers of science to look on the history of science. Why? Because not everything in the history of science is irrelevant to this epistemic question. Some things in the history of science are irrelevant to these epistemic questions, but others are not. I give you a simple example. For instance, it is well known that Kekule, who was the famous inventor of the benzene ring in chemistry, right? So the chemical formula of benzene can only be explained by assuming that the carbon atoms form a ring. So how did Kekule discover this hypothesis? He dreamt it. He discovered it by a dream. Of course, the fact that he dreamt it is in no way relevant for the question of the truth of the hypothesis. I mean, it turned out to be true, but that was confirmed when he, after the night when he dreamt it, went to his laboratory, very excited, and tested whether this hypothesis fits the experiment, survives critical tests, right? And it did. But the fact that Kekule dreamt it is irrelevant, clear. On the other hand, if you see like how Boyle and Mariotte came to the ideal gas law, they came it simply by extrapolating the measurements of pressure and volume of gases and extrapolated them into a curve. And of course, the fact that they discovered their method by the hypothesis, the ideal gas law, by the method of data extrapolation, that is relevant for confirmation. This method is already something which lends a certain kind of epistemic support to the hypothesis. So if philosophers of science look what scientists in practice really do, they find out a lot about methods that are used in science, and that is absolutely important for a philosopher of science to answer the question, what are the right methods which scientists should pursue to attain probable truth, right? I mean, by way of a comparison, if you want to write a book about bridge building, a manual about how to build bridges, right, you certainly won't do it out of your head, never having seen a real bridge before, right, how to build a bridge just by applying Newtonian gravitation theory. That would be crazy. Of course you will look about what kind of techniques bridge builders in the last centuries have used, and then write this manual with this knowledge. You will also apply Newtonian theory, but you will also look on the practice of bridge building. And the same thing is going on in philosophy of science. It has to have both a descriptive and a normative component. So, any questions until this stage? Yeah.
So the normative and descriptive dimension applies also to both the context of discovery and the context of justification?
I would say the normative dimension applies to the context of justification. I don't see a descriptive dimension here, except a trivial one, right? Of course, you can err in your logical proofs, right? But that is not. But the context of discovery has both a normative and a descriptive dimension, if I understand you right. Not really a dimension, but the context of discovery, or the context of the genesis of a hypothesis, involves a lot of activities of scientists where they employ methods which are normatively relevant for philosophers of science. Right. For instance, looking at how scientists extrapolate hypotheses from data may give you useful clues about inductive generalization procedures for the context of discovery. Or looking at the practice, how statisticians evaluate the significance of a difference hypothesis, like significance results. What is the practice? Gives you important clues for the context of justification of statistical hypothesis. Clues which you could never produce out of the head, right? Like, you know, if someone wants to invent a car, I mean, that's just a matter of evolution of culture. If someone invents a car, right, he would never be able to invent a car as perfect as that cars which we have today, which are the result of a 2-century history of evolution of cars. Yeah. Thousands of experts were involved, each improving the car a little bit. So only by looking on the actual evolution of cars, you get an up-to-date knowledge, expertise about cars. Like the same thing for philosophy of science. Right. Further questions? Yes.
So if the descriptive view seeks to describe what science has been in the past and how it operates, would it not need first a definition of what science is, and then ask the normative view to provide a definition?
Yes, there's a certain circularity involved here, if that is what you mean. And I admit it, and that's a problem. And you will see now how I try to solve this problem, if you allow me. Then, because when I proceed, I think this may be also the answer. So. How? The question was now, how How can it be that this descriptive and the normative side go together in one method? I mean, it's prima facie a very different thing to describe factual science and to say what good science is. So this is a model. The method is called the method of rational reconstruction, and this term was introduced by Lakatos and in the German-speaking country area by Stegmüller. Stegmüller was a very important German philosopher of science who transported a lot of the philosophy of science development and controversies which went on in the 40s, 50s, 40s and 50s, in particular in 60s, transported them and transmitted them to the German audience, right, to the German scientific community, so to speak, and made it possible that philosophy of science, and starting with the 70s, was a very successful development in the German-speaking area, right? Okay, so the method of rational reconstruction can be summarized in the following way. So what philosophy of science does is, let me just find the right place for the slides. Okay, so it develops models, right, of the most important parts of the scientific method in general, of the scientific procedure. So it develops models of observation, of experiment, of law. What is a scientific law hypothesis, theory? What is a confirmation procedure? What is a scientific test procedure? When can we say that a test procedure leads to the result confirmed, or confirmed to that and that degree? When does it lead to the result not disconfirmed, right? What is a falsification as an extreme case of disconfirmation? When can we say that a theory explains something successfully? What about the relation of the notion of causality in the notion of explanation? And finally, when can we say that one theory is more successful than another theory, even if the two theories maybe have different concepts, or even if they have just overlapping and identical domains, right? So all these questions are typical questions of philosophy of science. They developed formal and general models of these parts of the scientific method. And now I come to the major thing. So the requirements for a successful, so to speak, model in philosophy of science are fitness with the normative corrective, fit with the normative corrective, in a way I will explain soon, and fit with the descriptive corrective, in a way I will now explain. I start with the descriptive corrective. The so-called descriptive corrective of philosophy of science does not, and this is part of the answer, does not consist of all of the factual sciences, because there are a lot of controversies in sciences which are just undecided. I mean, we cannot demarcate science from non-science from the start, right? Without having already the results of philosophy of science, but we must start with some demarcation. So here we start with what I call paradigm cases paradigm cases in the positive and the negative sense. So paradigm cases of positive, of successful theories, like Newtonian theories, paradigm cases of confirmation, where all scientists agree. This makes up one part of a descriptive corrective of philosophy of science. Paradigm cases in the negative sense are theories which are clearly refuted. All of them agree. So like phlogiston theory in physics, clearly refuted, right? Or other Linnaean biology, like eternal species, clearly refuted by the findings which support evolution theory. These are the cases to which philosophy of science philosophers of science can refer, so to speak, prima facie. And their models should explain these cases, right? This is one requirement, the descriptive requirement. They should explain, should in any case be able to explain, right, why these unambiguously successful theories in science have been successful, and why these clearly refuted theories have been refuted and were unsuccessful, right? Philosophy of science should explain this. And at the same time, philosophy of science should be the models set up by philosophers of science should be justifiable by the normative corrective. And the normative corrective contains what is most important for it, a fixation of the goal of scientific knowledge. The rational reconstruction should not only explain the paradigm cases of successful scientific theories, but should also be able to justify these methods as optimal means for attaining the supreme epistemic goal of science. That is a normative part, right? It should be able to justify why these methods, which we set up, for instance, in the theory of confirmation, are optimal means, or at least very good means, right, to attain the supreme epistemic goal of science. And what is this goal? This is something about which I will speak more extensively in the next unit, in 1 week of now, in the next unit of my lecture. But so far for today, we start from the assumption that the supreme goal of science is finding true and content-rich statements, right? Laws and theories relating to a given domain of investigations. Like statements can be, for instance, law, hypotheses, or theories, but they can also be particular observation sentences. So finding true and content-rich statements, that relating to a particular domain of investigation. So that is the supreme goal. So this is already a subtle goal. In 2 ways. This formulation is already a very subtle thing in 2 ways. The first thing is there is a tension between truth and richness in content. So with content-rich I always mean rich in content, which mean a lot of consequences. In particular, statement is content-rich if it has a lot of empirical, practically testable consequences. So there is a tension between the probability of truth and the richness in content, which is quite obvious, right? If I'm interested in having as high truth chances as possible, the best thing for me is to assert hypotheses which have a little content, which are even empty, right? Like if I'm a weather reporter, I tell you, well, it will be raining tomorrow or it will be not raining, right? This assertion, it will rain or not, is certainly true, but empty in content, right? If on the other hand I want to I'm a weather reporter who wants to be up in the air and in everyone's mouth in the next days, right? And to announce sensational predictions, maybe I should say, I promise you the weather will be always sunny all the next 3 months, right? I mean, that's false, but it's rich in content, right? Of course, if it turns out that my prediction was false, I probably will be verbally beaten after some days. But, or if I'm technician, I'm, for instance, an expert in energy acquisition, I could tell you, well, the energy problem of the society will be solved or not in the next 100 years, right? Very interesting, right? But certainly right. Or I could also tell you, well, if I'm interested in content-rich statement, I've invented a perpetuum mobile, right? You know what a perpetuum mobile is, a machine who always produces energy without losing any energy. This is false, but rich in content, right? So you see already here what is the art of a good scientist. The art, I say, and the craftsmanship of a good scientist is to come up with hypotheses which are at the same time rich in content and probably true. That is very difficult, right? I mean, many mathematicians, right, come up with hypotheses which are very, very general, but at the same time have small content. You want to if you speak about all kinds of so hypotheses which are rich in content concerning reality, right, and probably true, that is a real difficulty, right? That is a real difficulty. So this is the first thing about this supreme goal in the sense of the highest epistemic goal, the most fundamental epistemic goal of science. The second thing is the notion of truth. What is the notion of truth, right? I mean, that is of course something which we speak about in the next unit, but just so far for today. If I speak like with a religious fundamentalist, and I say I'm interested in truth, in objective truth, but you just have your religious creed, which is has nothing to do with objective truth. The religious fundamentalist will tell me, no, you're completely wrong. I'm interested in truth too, but my truth is much more deeper than your scientific truth. I'm interested in the deep truth of religion, of God, right? So people understand the notion of truth in different ways. Therefore, we must make clear what truth means for us, right? And for that purpose, we need the second part of the normative corrective of philosophy of science, which is a kind of minimal epistemological model. The minimal epistemological model is at the same time, I would say, it consists of 5 epistemological assumptions. And these 5 epistemological assumptions are something where I claim which is assumed normally in more or less all kinds of scientific disciplines. And it makes clear what is meant with truth, right? And these 5 epistemological assumptions will be explained in the next unit, but so far for today, they consist of these 4 assumptions. E1 is the assumption of minimal realism, so it's the assumption that there exists a subject-independent reality. This is what I mean with minimal realism. There exists an independent reality which has properties which are independent from what I believe, right? But the realism is minimal in the sense that I do not assume here, like metaphysicians often assume, that all properties of the reality can really be discovered or understood or grasped by human mind, right? There might be that, like in quantum mechanics, some properties of micro-reality can never be understood in the correct way by humans. We do not assume that all aspects of reality can be understood. But we assume that there exists such a reality, and the notion of truth is just a correspondence of what we say in our statements with this reality. Where this notion of correspondence is understood in a structural sense, in an information theoretic sense, and not in a kind of metaphysical sense of mirroring or something like mirroring image or so. It's just an information theoretic notion, the notion of correspondence. Certain aspects of the structure of reality are isomorphically mapped into the structure of the content of our hypothesis. That is meant with the correspondence theory of truth. And this notion of minimal realism is also compatible with the notion of approximate truth or closeness to the truth, right, or probability and so on. The other aspects are fallibilism. Fallibilism, for instance, is an assumption that there is no golden pathway to the truth, right? Human opinions can always be in error. Right? There is no God who has implanted Platonic ideas into our unconscious soul, like many philosophers in the rationalistic tradition have assumed this. There is no so to speak, there is no kind of inner intuition which grants us truth, like also kind of religious fundamentalists would assume it. But those Plato, I mean, lots of rationalistic philosophers like Descartes, also like Leibniz, assume such a reservoir of intuitions. If we have access to them, then we see maybe the truth. Science doesn't assume it, right? So it's always this fallibilism. This is a kind of critical attitude. The third assumption is objectivity and intersubjectivity. Objectivity simply flows already from the assumption that there exists a mind-independent reality, right? Intersubjectivity is an important criterion for it. I will explain this in the next unit. The fourth assumption is a kind of minimal empiricism, which more or less says that the only way, the only direct contact which we have to the reality is not via intuitions, but via experience. Experience in the broad sense of this word, not maybe restricted to scientific measurement, experience, right? And so confirmation in the end must somehow, or justification of knowledge somehow must be based on experience. But not only on experience, but also on logic in the broad sense. This is the fifth assumption of the epistemic model, which I will explain in the next unit. So logic in the broad sense is needed in science to make the consequences of hypothesis clear, because only if you know the consequences we can test the hypothesis. So these are very briefly the contents of the normative corrective. And the method of rational reconstruction now is simply this: develop models of scientific procedures which on the one hand explain the descriptive corrective, explain the success of the successful theories, explain the failure of the non-successful theories, and which on the other hand can be justified as optimal means to reach the supreme epistemic goal of science under the assumptions of the epistemical model. And if that turns out to work, if such a double justification, normative and descriptive, can be really given, then the models of philosophy of science can be applied to controversial cases in the factual sciences. For instance, cases to help to solve unsolved problems. Of course, it may turn out that even these normative assumptions here may be revised. So, like in the early normative philosophers like Popper and Gerhard and logical empiricism, their normative assumptions here in the for instance, in the epistemological models were too strict. So it is also possible in philosophy of science, of course, that in the course of this process certain revisions on the normative side occur. I do not exclude this. There you have these errors here too. And this is my reconstruction of the method of rational reconstruction, and which also ends this first unit of my course. Before we end, I ask you, are there any questions, further questions to the last part of the course? Yeah?
Shouldn't the supreme goal of science include at least some reference to the application of science?
Yeah, here I have the arrow saying application. So if you have models, successful models in philosophy of science, then you can apply them to various controversies in different fields of science, including technology and so on, right?
But this doesn't belong to the supreme epistemic goal. Because the pragmatists, they would say the goal of science is its application.
No, the application is implicitly contained in the word. The connect, of course, you know, following, if you set up a list of epistemic values which are important in science, this is not the only value, it's just the most general value. But more special values, like deriving empirical predictions, having confirmed predictions, having causal explanations, and so on, being so to speak, all these more special values. For instance, being decomposable, a theory should be decomposable into different parts. Being logically decomposable is also a value, right? All these more special values are more or less means to attain this more general value. And the value of being practically applicable is implicitly contained in this word content-rich, rich in content, right? Because richness in content means primarily not having a lot of consequences which are untestable, but having testable consequences. And testable consequences are per se practically relevant, right? So, but there is nothing which can be said, nothing more specific about this possible practical relevance of science than this. Because I don't want to say science should be relevant, should be useful for the pharmaceutical industry, Well, I mean, that would be too special. That would be a conflation of epistemic and extra epistemic goals. But it should be practically relevant. That is what we can say. Further questions? Okay then, thank you for today.